Okay, real quick, I'm going to go through just the graphing part of it on the first page. With parametrics, make sure you realize that you have to determine an x and a y, and you're defining it in terms of a parameter, t. So I always think of t as time. So when you see t goes from 0 to 5, I'm going to make a chart. I'm going to look at things from 0 to 5 for t. So at time 0, when I put in t as 0, I get x is 4 and y is -3. When I put t as 1, so time equals 1, I get 7 for x and -2 for y. So once you get your chart filled out, really all then you're doing is graphing your ordered pairs. So I graphed 4, -3, 7, -2, 10, -1. So I graphed all of those points. It starts down here at 4, -3. It ends at 19, 2. So that graphs a straight line. I do need to show, parametrically, I need to show what direction it's going. So that's where the t's come in. So at t is 0, I started here. So to show that it goes in that direction, I need arrows to show that it is going in that direction. So this becomes a line, the line with a slope of 1/3. And again, I can tell the slope is 1/3 by looking at the difference of the y's. So every increase of 1 for y, the x's are increasing by 3. Okay, so then number 2. 2 has sine and cosine in it, so when we put in our t's go from 0 to 2 pi. So I just put in the 4 main ones. And you obviously could put in pi over 6, pi over 4, pi over 3, get a more accurate answer, but I know that this one is going to be some kind of a circle or ellipse because of the sine and cosine. So I just plug these numbers in. So when I put in cosine of 0 is 1, 20 times 1 is 20. Sine of 0, when I put it in for the y, is 0, so that's why that's 0. If I go to pi over 2, the cosine is 0, the sine is 1. At pi, cosine is -1, so that's where I got the -20, and sine is 0. So I went through those ordered values of t to get my ordered pairs, and I know this is going to be an ellipse. So when I look at it, I started at 20, 0. I went up to 0, 30, then -20, and it's going in this direction. So see how I have the arrows. And I just signified because I wanted to show that it stops at from 0 to 2 pi. I just put start and end there. Like it's not going to keep going around the circle forever. It's going to start at this point and go around this direction and stop at that point. You really don't need to write that, but I just like to do that for myself to know that's really what happened. So this is an ellipse. The ellipse has a center at 0, 0, and it has vertices of 20, 0, 0, 30, -20, 0, and 0, -30. So I should be able to describe what that graph looks like, but don't forget the arrows to show the direction it goes. All right, and then number 3. With number 3, I put in t values. It says t is greater than. Make sure you realize that. You're looking for t's that are greater than -2. -2 is less than t. So I started with -2. I just went until I saw that the pattern was kind of going to stop, or what kind of look at what the pattern was. This goes on forever, realize. So I put in -2 in for x in the x equation, and I got 8. Put it in the y, and I got 0. Put in -1, 0. So I put these values of t in. These are the ordered pairs I got. So when I went to graph it, something odd kind of happened when I went to graph it. You should see it started at 8, 0. Then it went to, which is up here, so I put the start right there. Started at 8, 0. Then it went to 5, -3. Then it went to 4, -4, which is down here. Then it went back again to 5, -3, and to 8, 0. So it's hard to show that, but what I did is I just said it started here. I put an arrow this way, so it started going down this way. Once it got to here, it started coming back, so I drew another arrow going in the other direction. And then it's going to keep going because it's greater than -2. The pattern's going to keep going that way. So on this one, I want to make sure I put an arrow at the very end of the line, because that shows me that, okay, this is the pattern. It started here. Now I see an arrow. It comes back, bounces back this way, but now it's going to keep going forever because of that arrow. So make sure you signify that. So this one is a line. The slope is 1, and again, you can see that by every increase In the y, the x's are increasing by 1. Okay? All right, I just wanted to talk about the calculator a little bit too. So if you are using your calculator to check these, first of all, go to mode. Make sure that you are in parametric mode. So that's it here. And then also make sure, if you're going to do any of the angle ones, that if you're in degrees, then you put things in like 0, 90 degrees. So the one we were doing, number 2, you would want to be in radians. So kind of decide what your equations look like. What's your parameters? Are your parameters in degrees or are they in radians? If they're in radians, then you should make sure that your calculator's in radians. All right, but I'm going to do example number 3, so I don't really care if it's in degrees or radians. If you go to your y equals, when you type it in, remember this x value gives you your t. So you're going to type t squared plus 4, and for y, t squared minus 4. Go to your window. The only thing you really have to do is set your parameter. So I could go -2 to, I can't write infinity, but I can go -2 to 10. I mean, my chart only went from -2 to 3, but you definitely could, decide what you want to go by. Let me go -2 to 5. And then I'm going to do my t-step, I'll do 0.5. So that'll give me a few points that it's going to graph. And then I just have to do a zoom fit. So set your parameters and then do zoom 0, zoom fit. And there you saw that it started going down and then it came back up. I'll change my window so you see that. I'll make it go a little bit slower. I'll go by 0.1s. So changing the step is only going to slow it down. So when I hit graph, see how it goes down to that point, and then it comes back up, and it's going to keep going. Now, if you want that ball, so you can see it a little bit better, remember you go to your y equals, and arrow over, and pick this one. If you keep hitting enter, you'll see all the different options for your line. And you want to pick the one that looks like that. That will get you that, that you can see a little bit better when it moves. So that's kind of what the graphing piece is of that. Just pick your parameters, do a zoom fit, and then if you want to adjust your window from there, you can. But you should be able to do both. You should be able to use your calculator, and you should be able to make a chart like we did on the sheet. So that's the graphing piece of what's on the test.